Hello, allow me to briefly introduce Kollaps, a decentralized and dynamic topology emulation tool, which is the result of joint work between researchers from the University of Lisbon in Portugal and the University of Neuchâtel in Switzerland. As developer of distributed applications, you certainly know that the network has a big impact on application behavior and performance. And this is essentially the objective of Kollaps, to allow you to experiment with varying network conditions and varying fault conditions, and allow to ask the questions about your system, such as what is the impact of halving the network latency in application throughput? How would my application behave if I have this given packet loss rate? Or if my application is under link flagging? The goal of Kollaps is precisely to emulate these experiments, and we depart from the state-of-the-art systems by not emulating the full state of the network. And why is that? Because this is rather expensive. Emulating the state of routers and switches is difficult to scale as the topology scales. So we rather focus on a simplified emulation model that allows us to emulate only the end-to-end properties. And therefore, this allows us to preserve accuracy while still being able to scale to a very large number of nodes. The experiment that you can build is described in a very simple and compact language. This is the general architecture of Kollaps. So we start with a system described in this language that I showed you. We assume the existence of a set of physical machines in a cluster, for instance, and we pick the application that runs on containers. We deploy it on the system together with Kollaps, which would allow you to emulate the network you just specified. Rather than going over the details on how Kollaps works, I'm going instead to show you a simple use case on what Kollaps can be used for. For instance, consider the following scenario of a Cassandra deployment on Amazon EC2, where we have 4 replicas in Frankfurt and 4 replicas in Sydney, and 4 clients also in Frankfurt. So we run the system on EC2, we gather throughput and latency metrics, and then we run the same experiment on Kollaps in a local cluster with similar hardware, and these are the results. So we have a throughput latency plot, and as you can see, the results we obtained on a real deployment on EC2, the red line, are very, very similar to the ones obtained with Kollaps. So this shows that despite we are simplifying the emulation model by not emulating the network state, we still achieve good accuracy in a real system. The other key advantage of Kollaps is that it allows you to easily play around with what-if scenarios. So let's try to measure the impact of halving the network latency in the previous use case. And this would correspond to move some of the replicas from Sydney to Seoul. And this is the results. And as expected, we can see that there is a substantial impact in throughput and also on latency. An interesting thing is that we can do this very, very easily and do these kinds of experiments where you change network properties and subject the system to faults and are able to assess the overall system behavior. To conclude, Kollaps is a centralized topology emulation tool. It emulates the emerging end-to-end properties rather than the internal network state, and this is what allows us to scale to very large systems while still preserving the accuracy of the emulation properties. Kollaps is available as open source on GitHub, so please check it out. Also check the paper. We have lots of experiments when we discuss the overall system design there, and we are looking forward to a fruitful discussion during the conference. Thank you.